Dr. K. Viswanath Allamraju, Institute of Aeronautical Engineering, Dundigal, Hyderabad, India. In this session, we are going to study the transformation of plane stress. We are going to consider a cube in three-dimensional having stresses sigma x and sigma y are acting on axis x and axis y directions, and also the shear stress, that is tau xy, the complementary shear stress, is associated with this element. Now here we consider the plane stress. Here the plane on this plane, what is sigma z equal to 0, stress in z axis, and tau zx and tau zy are also 0. So we are considering the plane, and the stress components which are existed on this plane is sigma x, sigma y, and tau xy are associated. Now when it is rotated with an angle about z axis theta, then the new axes are x dash, y dash, and z dash. Here z dash equal to z because it is rotating about z axis, but the new stresses values are sigma x dash, sigma y dash, and tau x dash, y dash. Now we are going to find out the sigma x dash, sigma y dash, and tau x dash, y dash in terms of sigma x, sigma y, and tau xy. Now here, when we consider the triangular element, the prismatic element, that is having area of cross section del A, with resolving horizontal and vertical components. By horizontal component, that's delta A cos theta, and here it is delta A sin theta. Now these components are resolved on coming to this figure B represents, that is sigma x del A cos theta. This del A cos theta is in horizontal plane. Sigma x into del A cos theta, that means that the force which is acting on this sigma x del A cos theta, and sigma tau xy del A cos theta, tau xy del A sin theta, and sigma y del A sin theta on this horizontal plane, in this plane. Now here, that is the normal stress, that is sigma x dash del A, and parallel to this plane, parallel to the plane, that is tau x dash y dash del A. After that resolving, we have to apply after these components, we have to apply equilibrium conditions in x and y directions. Then sigma fx dash equal to 0, that is sigma fx dash equal to, that is sigma x dash times del A. Sigma x dash del A, it is going towards x direction in this. Then minus sigma x del A cos theta times, then it is cos theta, minus tau xy del A cos theta times sin theta, minus sigma y del A sin theta times sin theta, minus tau xy del A sin theta cos theta, that is equal to 0. And another equilibrium equation, sigma fy dash equal to 0. So sigma fy dash, this fy dash direction which is acting here, that is parallel to the section del A. Further section, that is tau x dash del A, is parallel, that is tau x dash del A plus sigma x del A cos theta and sin theta, sigma x del A cos theta and sin theta, minus tau xy del A cos theta, this component, tau xy del A cos theta and times cos theta, minus sigma y del A sin theta, it is in opposite direction, sigma y del A sin theta times cos theta, plus tau xy times del A sin theta, this is del A sin theta times sin theta equal to 0. So here we have to consider this is equation 1 and it is equation 2. From the equation 1 we can observe the sigma x dash value, and from equation 2 tau x dash y dash value can be calculated. Now from those equations, sigma x dash, the sigma x dash equal to all these terms sent to right side of equality, then what happens, equal, then sigma x del A cos theta and cos theta, that is del A cos square theta, del A will be cancelled on both sides, then sigma x dash equal to sigma x cos square theta plus tau xy del, that is cos theta sin theta. Here tau xy cos theta sin theta, that means tau xy 2 sin theta cos theta, that is tau xy times sin 2 theta. Here another term sigma y times sin square theta. Now those are the terms here. Sigma x cos square theta, sigma y sin square theta, and 2 times tau xy sin theta cos theta, that means tau xy times sin 2 theta. Now here, that is from equation 1. Here in the place of cos square theta, then substitute, that is cos square theta equal to 1 plus cos 2 theta by 2. And in the place of sin square theta, this term, that is 1 minus cos 2 theta by 2. Then after substitution, the equation becomes sigma x dash equation, that is sigma x dash equal to sigma x times 1 plus cos 2 theta by 2 plus sigma y times 1 minus cos 2 theta by 2 plus tau xy 2 times sin theta cos theta, that is sin 2 theta. This is the equation. Now from second equation, from equation 2, tau x dash y dash, the common term in all terms are, there is del a, there is delta is cancelled, then sigma tau x dash y dash equal to sigma x here, sigma y. Here sin theta cos theta, sigma x, that is sigma y, common term is sin theta cos theta, make it a common, and also tau xy here cos square theta and tau xy sin square theta. Then from this tau xy common, then cos square theta minus sin square theta, that means cos 2 theta comes here. After simplifying and separating and make it common of the terms, common terms from the individual terms, then tau x dash y dash equal to minus of sigma x minus sigma y sin theta cos theta plus tau xy cos square theta minus sin square theta. So this is the becomes equation 4. Now this equation, then sigma x dash y dash times minus sigma x minus sigma y. If you multiply both the numerator and denominator with 2, then 2 times sin theta cos theta, that is sin 2 theta by 2 will come. This is tau xy cos square theta minus sin square theta, that is cos 2 theta. Now final terms, equations are the equation 5 and it is equation 6. This minus of sigma x minus sigma y by 2 sin 2 theta plus tau xy cos 2 theta. This is equation sigma x dash equal to sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 cos 2 theta plus tau xy sin 2 theta. Okay. So these are the, what is sigma x, sigma y? This is the stress component acting along axis x and axis y. And tau xy is the simple shear stress. It is along the plane x and y. Because it is parallel to the cross section it acts. It is acts normal to the cross section. That is sigma x. This is the stress value in direction of the x axis, sigma y, and the stress, normal stress value in the direction of the y. So this sigma x dash and tau x dash y dash. Now another term, this the sigma y dash are to be calculated, but very simple. We can resolve along the y axis, or another shortcut is that in the place of theta of sigma x dash, because this y dash is 90 degrees to the axis x dash. So substitute in the place of theta here 90 plus theta. Then cos 2 times 90 plus theta and sin 2 times 90 plus theta. Then you can get it the value of sigma y dash. That sigma y dash equal to sigma x plus sigma y by 2 minus sigma x minus sigma y by 2 cos 2 theta minus tau xy sin 2 theta. Now the expression for the normal stress, what I explained here, let me read. Sigma y dash is obtained by replacing theta in equation, the above equation of sigma x dash by the angle theta plus 90 degree, because it is rotating 90 degree. Then that indicates the y dash axis forms with the x axis. Since cos 2 theta plus 180 degrees, that is minus cos 2 theta, sin 2 theta plus 180, sin 180 plus 2 theta minus sin 2 theta. So substitute back those terms in equation, in sigma x dash equation, that it becomes sigma y dash. Then sigma y dash equal to sigma x plus sigma y by 2 minus of sigma x minus sigma y by 2 cos 2 theta minus tau xy sin 2 theta. Now here this is the equation. Sigma x dash is equation 5 and the sigma y dash is equation 7. Then sum of equation 5 and equation 7, then what it comes, that is sigma x dash plus sigma y dash equal to, what is sigma x dash's term is, this is the sigma x plus sigma y by 2, sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 cos 2 theta plus tau xy sin 2 theta. That is sigma x term. What is sigma y dash term? Sigma x plus sigma y by 2 plus minus sigma x minus sigma y by 2 cos 2 theta minus tau xy sin 2 theta. Now cancel the same terms with the plus and negative sign. There is the plus sigma x minus sigma y by 2 cos 2 theta and it is minus sigma x minus sigma y by 2 cos 2 theta got cancelled. And tau xy sin 2 theta, positive tau xy and negative tau xy sin 2 theta get cancelled. Then what left? 2 times sigma x plus sigma y by 2. 2 times sigma x plus sigma y by 2, that is nothing but sigma x dash plus sigma y dash equal to sigma x plus sigma y. This is what obtained. So if we equate, if we sum of the sigma x dash and sigma y dash equal to the direct stresses of the sum of the direct stresses, that is in along x axis and y axis, that is sigma x plus sigma y. So the point is that interpretation, even after rotating some angle theta from these equations, the sum remains the same, that is sigma x dash plus sigma y dash equal to sigma x plus sigma y. Okay. Next, we have to, from these equations, we are going to find out some other terms, that is what is the principal stresses and maximum shearing stress. So here the equations are already calculated, that is sigma x dash equal to sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 cos 2 theta plus tau xy sin 2 theta. And about the shearing, the shear stress, about the after new rotation of the axis with theta rotation, the tau x dash y dash, that is minus of sigma x minus sigma y by 2 sin 2 theta plus tau xy cos 2 theta. These equations are known as parametric equations of a circle. These are the equations. Okay, from these two equations we can derive other equations that just now we have derived, that sigma y dash also. So these are the important equations. From these equations we can derive maximum principal stress and minimum principal stress, and also the angle turned, what is the angle of the principal plane. Now here from this, the principal plane, from this figure you can understand, it is the Q is the point about which it is rotating, about z axis it is rotating. This is along x dash, that is the maximum principal stress is acting, that is sigma max. Along y dash, that is the minimum principal stress. So what is the angle turned by the principal plane? What is the theta p? The tan times tan of 2 theta p equal to 2 tau xy by sigma x minus sigma y. So from this plane is known as the principal plane. Along the principal, this is the principal plane. What is the principal plane and what is the angle of the principal plane? Here theta p. From this formula we can observe the angle with the x-axis of the principal plane, that is 2 times tan 2 theta p equal to 2 tau xy by sigma x minus sigma y. This is theta p, this is 2 theta p. Okay, total, that is 2 times 2 theta p. Now what is sigma maximum, what is sigma minimum? Now what is sigma max and sigma min? Further simplification, sigma max and sigma min equal to sigma x plus sigma y by 2 plus or minus sigma x minus sigma y by 2 whole square plus tau xy whole square under square root of tau xy square. Sigma maximum, the sigma maximum equal to the maximum stress, that is sigma x plus sigma y by 2 plus times under square root of sigma x minus sigma y by 2 whole square plus tau xy square. And minimum, sigma minimum equal to the negative term, that is sigma x plus sigma y by 2 minus of sigma x minus sigma y by 2 whole square plus tau xy square. Now here this component is known as average stress, that is sigma average. Okay, and this component is the resultant, or that means sigma maximum equal to sigma average plus resultant stress, sigma minimum equal to sigma average minus R. So if it is a plus R, positive resultant stress, by adding the average normal stress, that is the maximum, and the minimum is average sigma average minus R, that R is the resultant stress, that is minimum stress, minimum principal stress. So the direction of the maximum principal stress is along the direction of the x dash, new principal plane, and the direction of the minimum principal stress is along y dash. Okay, along y dash, minimum principal stress. So now we calculated here what is maximum principal stress and what is the minimum principal stress values. Now from this, these are the analytical method we calculated. Now what is the another method in order to calculate sigma n, normal stress and shear stress, okay, for the cases of two perpendicular direct stresses and along with simple shear stress, the tau xy complementary shear stress. This method is the graphical method. So far we have studied analytical method. Now here it is graphical method. So if we know, suppose sigma x and sigma x values along x-axis and sigma y and tau xy and angle theta are known, then how to find out sigma n and tau by using graphical method. That graphical method is known as a Morse circle method. It is derived by Morse circle method is derived by the Mohr, that is Otto Mohr, is the person propagated this Morse circle method. Now here step by step we learn in this Morse circle method. In this Morse circle method, first draw after known values, sigma x known, sigma y are known, and tau xy known values, and theta also known. After knowing this, the unknowns are to be found. Sigma n and tau are to be found. Now first known values, take a scale, linear scale. Suppose stress sigma x, sigma y and tau xy are always in Newton per meter square. This Newton per meter square converted into the linear scale, and suppose sigma x equal to 100 Newton per meter square, sigma y equal to 200 sigma y become less value, that is 50 Newton per meter square. Consider 10 Newton per meter square equal to 1 centimeter. In that manner you consider it. I am showing you suppose example. So after this, take a scale, required scale. This required scale, with the required scale, draw first step sigma x. From any vertical line, take a distance towards right direction sigma x. That is sigma x equal to sigma x value. That sigma x value, that is from O to L. OL gives sigma x. Then from O, then take a distance of sigma y value, that is OM. Draw a line OM. This is the second step, sigma y. After sigma x and sigma y, the third step is The third step, take from L, this OL, from this L, draw a perpendicular line. That value shows tau xy, that is LT. That LT equal to tau xy. Similarly, from M to S, that is also tau xy. MS, M to S, tau xy. That is the third step. The fourth step is join S to T. Join S to T. This is the fourth step. Fourth step is join S to T. Then it intersects the center at N. That ST line, TS line intersects the horizontal line OL at N point. With the help of compass, take the distance from NS. Take the distance N to S or N to T. Draw a circle. This is the fifth step. Circle. Okay, after drawing that circle, draw the circle. That circle is the Morse circle. The next sixth step is from NT is the reference line. We know the angle theta. Make it 2 theta and draw a line. That line is NP line. That NP line, you draw NP line. This NP intersects the circle. Mark it point P. NP line. After drawing this 2 theta, it intersects at P. So mark the point P. Then from that point P, draw a perpendicular line. Intersects at Q. And join another line, that is with OP. Join another line OP. So the distance, you measure the distance O to Q. That gives the value of normal stress. OQ gives sigma n. And you measure P to Q, vertical distance, PQ, from point P to point Q. This distance gives the value of the shear stress. And the distance from O to P, diagonal distance, gives the value of resultant stress. Now this OP square equal to, from this figure, OP square equal to OQ square plus PQ square. From that, OP equal to under square root of OQ square plus PQ square. What is that OQ? OQ equal nothing but sigma n square. So now the resultant R equal to sigma n square plus tau square. So this is the resultant stress. Now if you measure the angle, what is the making this resultant? This OP, the resultant stress making, what is the direction of the resultant stress? That equal to tau by sigma n. Tan phi is the angle making phi. Tan phi equal to tan phi from this triangle OPQ. From the triangle OPQ, tan phi equal to opposite side by adjacent side, PQ by OQ. What is the value of the PQ here? The PQ here, it is PQ is tau. What is that OQ? OQ is sigma n. This phi is known as angle of obliquity. Then phi equal to tan inverse of tau by sigma n. So this phi is known as angle of obliquity. This is the graphical method, or another name is called Morse circle method, by which we can calculate sigma n and tau. Sigma n, that means normal stress and shear stress. So the given data, very important method here in this problem, all sigma x, sigma y and also tau shear stress also presented under the angle with which the plane is making. This is the plane is making. That angle is, okay, theta angle. So by using this method, suppose in this sigma tau is 0, then how to calculate, how to measure it? If the tau is 0, how to measure the sigma n values? Or if sigma y is 0, so we have to make it, those things are absent, absent, then we have to draw the Mohr circle method. We have to find out sigma n and tau. So the steps are mentioned here. If you follow these steps, you can understand completely the Mohr circle procedure. These are the 7 steps of procedure. The first step, let me coincide. Use some suitable scale. Measure OL equal to sigma x, OM equal to sigma y along the axis OX. First step indicates use some OL equal to sigma x. This is the point O and it is L. OL equal to sigma x. And another one, OM equal to sigma y. This is the value OM. This is the OM value and it indicates sigma y. That's the first step. The second, at L, draw LT perpendicular to OX and equal to tau xy. This is LT perpendicular to OX line, perpendicular to OX line, and that value indicates tau xy. That is the second step. So here the tau xy, why we have drawn downwards? Because tau xy is acting respect to the plane across which sigma x is acting, tending to rotate in the anti-clockwise direction. So if it is rotating in the anti-clockwise direction, it is rotating on the sigma x. If you consider, we have to consider sigma x value. Sigma, it is in anti-clockwise. Anti-clockwise tau xy gives negative tau xy. That's why we have drawn downwards. Okay. And another is sigma y. Here y we have drawn SM. This also gives tau xy. Why have we have drawn upwards? Because it is in clockwise direction on sigma y side. This tau xy is clockwise, is so positive. That's why we have drawn this tau xy is upwards. This is tau xy is upwards, is positive direction. Here it is negative and here it is positive. Okay. So MS is positive, this is in clockwise direction. Why it is sigma y position? Because on the sigma y, tau xy is clockwise rotation. This is in clockwise. That's why we have done positive. Suppose it is rotating counterclockwise direction, then it comes SM downwards and it goes up. Then the next step is similarly make MS perpendicular to OX. This is the MS perpendicular to OS. Then join, fourth step, join ST to cut the axis line. Join ST to cut the axis line. What is the step point is? Fourth step. Then it intersects at N. The fifth step, N as a center and NS or NT as radius, draw a circle. So this is the center and a circle draw, fifth step. So in this manner, these are the various steps. Okay. Now that is the fifth step. Let me complete remaining 2 steps so that you can understand. At N, make NP an angle 2 theta with NT in the anti-clockwise direction. 2 theta in the anti-clockwise direction. Make it NP. Then draw PQ perpendicular to the axis. This is the PQ perpendicular to the axis. This is the 6th step. 6th or 7th? Yes, 7th step. This is 7th step. This PQ will give tau, while OQ will give sigma n and OP will give sigma r. This PQ gives tau value, OP gives sigma r value, and OQ gives sigma n value. So it is a 7 steps procedure to draw the graphical method or Mohr circle method to find out sigma n and shear stress tau by using this method that is called Morse circle method. So we considered here that for the case of two perpendicular direct stresses and along with simple shear stress tau xy. The two perpendicular direct stresses are sigma x and sigma y. Sigma x and sigma y are direct perpendicular stresses, and shear stress is the tau xy is the shear stress. Okay, so this is the procedure. Let me summarize what we have studied in this class. We have studied in this class transformation of the planes and Morse circle method. The transformation of the planes we considered here. The plane stress means exists with this condition sigma z, tau zx and tau xy are 0, tau zy are 0. And when it is rotating with an angle theta about z axis, then z dash equal to z and x varies to x dash, y go to y dash, theta motion. Then we have to find out sigma x dash, sigma y dash and tau x dash y dash in terms of sigma x, sigma y and tau xy. So after calculating this, now sigma x dash equal to equation 5 sigma x plus sigma y by 2 times sigma x minus sigma y by 2 cos 2 theta plus tau xy sin 2 theta, and tau x dash y dash in terms of sigma x, sigma y and tau xy. Then similarly sigma y dash also calculated. Then the angle making these two equations sigma x dash and tau x dash y dash are known as parametric equations. That means of a circle. So from this circle we have drawn Morse circle can be drawn. Now the angle made by this plane theta p, that's principal plane, is 2 tan 2 theta p equal to 2 times tau xy by sigma x minus sigma y. Now the principal plane on that, the shear stress equal to 0. By using shear stress equation equal to 0, then only you get it this equation. Then we have to find out, after knowing this theta p, substitute back tan 2 theta p equal to 2 times tau xy by sigma x minus sigma y. Suppose it is theta p. 2 times, that is opposite side by, that is opposite side 2 tau xy by adjacent side sigma x minus sigma y. What is hypotenuse here? The diagonal side is square root of sigma x minus sigma y whole square plus 2 tau xy square. Okay. Now we have to substitute this 2 theta p. We want sin 2 theta p. Sin 2 theta p means opposite side by hypotenuse. That means 2 times tau xy by under square root of sigma x minus sigma y whole square plus 2 times tau xy whole square. What about cos 2 theta p? Cos 2 theta p equal to sigma x minus sigma y by, that is sigma x minus sigma y whole square plus 2 times tau xy whole square. Substitute the sin 2 theta and cos 2 theta back in equations of these two equations, cos 2 theta and sin 2 theta. Then make it simplify. Similarly tau x dash y dash. Then we can obtain the equation that is sigma x, sigma maximum and sigma minimum. The sigma maximum, sigma minimum, sigma x plus sigma y by 2 plus or minus sigma x minus sigma y by 2 whole square plus tau xy square. Those terms should be under square root. So positive, this sigma x plus sigma y by 2 is the average and this component is the resultant. So average, sigma average plus or minus r, that gives sigma max comes sigma average plus r, and sigma minimum gives sigma average minus r. Those values gives the maximum and the minimum stresses on principal plane. Those are the principal stresses are being calculated. The next part is how to find out another method that is called Morse circle method. I have explained in detail Morse circle method. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.